Hello, my name is Connor Laufenberger, and I'll be doing a lesson on cross-sections. A cross-section is a three-dimensional object made from taking the base of a shape and applying it to the designated section at an infinite number. Let's start on the first practice problem. So it says the base of a solid S is the region bounded by parabolas x squared equals 5y and y equals 6 minus x squared. Cross-sections are perpendicular to the x-axis and isosceles right triangles with the hypotenuse lying on the base. So the first thing let's do is draw a picture of the graph. The two parabolas will look like this and like this, which this is our designated section. So since it's isosceles right triangles with the hypotenuse lying on a base, let's draw that with our right triangle here. This is the side, and this is s root 2. Therefore, the area of this would be 1/2 times s over root 2 squared, which is 1/4 s squared. Now, to find the x interval, we set the equations equal to each other, so we get x squared over 5 equals 6 minus x squared. X squared equals 30 minus 5x squared. 6x squared equals to 30, and then we get x equals plus or minus root 5. So this would be our equation. Negative root 5 to root 5. And since this parabola is the one, what is that? That's 6 minus x squared is the one furthest away from our axis. That's the one we'll have subtracting from the other one. So we have x squared over 5 squared dx, because the entire integral portion is our s, and so we have to square it. And then we keep simplifying our integral. 6 minus 6x squared over 5 squared dx. Doing the squaring portion now. Doing a little bit of calculator work here. Now we're plugging in our x points. And we'll get this really long equation. Times 5 root 5 plus 2.88 root 5. Notice that the second part is the same as the first part, so technically we could just do it 1/2, but I'm just going to multiply it all out. And your final answer is 21.466. And that's the answer to the first one. Okay, now let's go on to the second question. The second question says the base of a solid S is a region bounded by y equals cosine x and y equals 4x squared. Cross sections perpendicular to the x-axis are quarter circles. I actually made a shortcut worksheet. For the example we did above, it was a isosceles right triangle with the hypotenuse lying on the base. And you saw how we solved for the area of this, so I've made a cross-section kind of shortcut list, which is all the areas for each shape. So you could just use this list instead of doing the work for each shape. So the first thing we do again is draw a picture. Here is our cosine. Not a very good looking cosine graph, but it'll work. And then here's our parabola. So this is our section we are looking for. And again, I have on this worksheet that a quarter circle is pi over 4 s squared, but let's do the work for it anyways. So this would be s, 1/4 pi s squared, since s is our radius, which is pi over 4 s squared. So that also checks out. And for this equation to work, we must find the x-intercepts. And the only way to do that pretty much is to do it on a calculator. So I already have the graph set up right here. And we're going to click calculate. I'm going to go to the intersect. We're going to choose the first one, the second one. And it gives us the point, I don't know if you can see it, but it's 0.472. The x-axis right there. So our interval is from negative 0.472 to 0.472. And again, since our cosine graph is the one above, cosine x minus 4x squared dx. Once we plug this equation into our calculator, we get our final answer of 0.395. And we are finished.